Configuring for recoverability. In this nugget, we start to delve into the largest section of the 053 exam as previously discussed, and that is disaster recovery in Oracle Database 11G. The specific exam objectives that we're covering in this nugget are what I haven't listed but will list right now, sources of failure, just so we understand the main reasons why a disaster recovery procedure may become necessary, and then we'll look at some specific methods for setting up our Oracle server for maximum flexibility in recoverability. Specifically, multiple archive log destinations. That's going to involve a little bit of review to make sure we understand what the redo log does and why it's important. I would say mandatory to configure log archiving. We'll then open up RMAN. We're going to be spending a lot of time with RMAN throughout this entire course. Retention policy is just one of several configurable properties of RMAN. Retention policy is going to instruct RMAN how long we want to keep our Oracle database or object backups. And then we'll examine the flash recovery area, which is one of so many automation technologies built into Oracle. It makes backup and restore so much easier, especially when you combine the flash recovery area with automatic storage management, or ASM, as we looked at in the previous nugget. Let's get started. We're going to begin this nugget by examining the major types of failures that occur in Oracle database. You see that I've divided this slide into 3 columns. A general type of failure, the most probable cause of that failure, and then most importantly, from a DBA perspective, what can we do about that problem? So at the most granular level, we have what's called statement failure. And this is when the user and or your application attempts to enter data into an Oracle table that's invalid. Now, the cause there could be human error on the part of the data entry operator, it could be a code error in your application, or it could actually be a code error in terms of the schema object itself. Maybe you have table or column constraints set incorrectly. Another possibility that could result in statement failure is a disk space problem. You may just not have enough space to accommodate, say, the creation of a new table or the introduction or inserting of rows into that table. That's going to obviously cause a statement to fail. The general solutions to the problem of statement failure include training. Now, this is going to be training on a couple of fronts. It's going to be training the end users so they're fully familiar with the line of business application that reads and writes to and from Oracle. Also training your own development staff. Some shops have a clear partition between the system admins and the developers. In some small shops, you might have both of these roles on your desk. The reason why the communication is important between the sysadmin side and the development side is the allocate space issue. The coding is going to be clearly a developer fix, but if the problem instead happens to hit your infrastructure, your disk subsystem, that again is going to require education and communication on both sides of this proverbial fence. Another type of failure is a user process failure. You'll remember in the previous nugget when we talked a little bit about the components of the Oracle database instance, and we have the system global area, the program global area, and the user global area, with the user global area being memory space devoted to each user connection. Now, a user process failure is an abrupt termination of that user process. This could be a dirty disconnect. In other words, the user has not gracefully disconnected from the instance, and that can be, again, an education issue, or it could be perhaps a flaw in your middle tier or front end application. Bottom line is, as a DBA, generally speaking, there's not much that you need to do unless this is a clear education problem or a problem with your LOB application. Oracle has devoted processes for cleaning up connections. The process will look for idle connections as well as connections that have been abruptly terminated. Any uncommitted changes to the data will be rolled back. Any locks that were handed to those users will be freed, and therefore other users will be able to come back into the database. Now, if a user does have a dirty disconnect, they may initially have a problem reconnecting until the cleanup occurs, after which they can establish another network connection. A network failure can be software or hardware related. On the hardware side, it could be a downed network connection. Maybe there's there's a physical problem with your Oracle server's network interface card, or maybe there's a media problem, that is a fiber optic or Ethernet copper cable may have interference or an actual cut in it, depending upon what's going on in your infrastructure. Maybe there is a switch in your LAN infrastructure that had a power outage and is therefore affecting connectivity to Oracle. There's a lot of network administrator type stuff going on here in terms of isolating a network problem. On the software side, of course, it could be the NIC driver, but an Oracle specific issue would be a downed, corrupted, or otherwise problematic listener. We'll remember that the Oracle listener is the software endpoint to which users connect to a particular Oracle database. How do we fix this? What are the main solutions? From both a hardware and a software perspective, redundancy is really the key to a high availability network connection to Oracle. Now, redundancy in hardware means maybe we have the Oracle server outfitted with multiple network interface cards. This gives us not only more than one point of failure from the NIC or network interface card perspective, but if those NICs are connected to different switches, again, you're creating redundancy on many different levels. We also can configure multiple listeners for Oracle. Now that's going to increase the complexity of your user's experience. tnsnames.aura, their listener connection file, for instance, is going to have additional entries in there to connect to the same database. It all depends upon how important avoiding the single point of failure of a single listener or a single network interface is to you in your shop. Now, how about if the entire instance goes down? The memory structures, the processes that run in the background, this could happen for a variety of reasons. It could be a process failure, it could be a power failure, it could be a failure in any or all levels of hardware. Maybe a fan conked out in your Oracle server, the server overheats, and then the system shuts itself down to protect itself. What are you going to do once you correct whatever problem it is, bring power back, replace a piece of hardware, whatever, and you restart the server? Chances are, if the server went down just abruptly, then we're talking about an inconsistent shutdown of the Oracle instance and associated database. Again, as a DBA, hopefully, you don't have to do anything to bring the Oracle database back to a consistent level. You simply restart the database, the instance in the database, and Oracle will initiate what's called crash recovery or automatic instance recovery. So what it's going to do is automatically roll back any uncommitted transactions that are there using undo segment data. It'll roll forward committed changes that are in the, you guessed it, online redo log files. So the good news is Oracle should be able to get back up on its feet if you do have an instance hang or crash that requires you to do a cold shutdown and cold startup of that server in a dirty way. Finally, we have media failure. Now, what's that? This is definitely, to my mind, the scariest type of failure because it deals with a failure of your storage subsystem in most cases. Your disk, or a disk, I should say, in an array situation, a disk controller fails. From a logical perspective, you would consider a user process performing a drop accidentally, dropping a table. That could also be construed as a media failure because unless we have those rows stored in a good backup, they may be gone forever. You see what I mean? But of course it's scary because if we don't have, like I just said, the data backed up, the failure of a disk or disk controller could put us in a world of hurt and quite honestly might result in what some call a resume generating event. In other words, something that could cause you to lose your job and have some explaining to do during future job interviews. The way we resolve media errors is by using restoration and recovery. Now, these are separate terms. I mentioned that if the instance goes down suddenly and you restart, Oracle will perform recovery automatically, and that's true. Restoration refers to restoring the missing data. That is to say, if you have a disk failure and you lose one or all of your data files, you'll need to use RMAN or another tool to restore good backups of those data files. So to restore means to put back in their original place the missing assets. Recovery deals with making sure the data is consistent. That is to say, ensuring that any uncommitted data is rolled back and any committed transactions that exist in the redo log files that you have handy are placed back into the data files for permanent storage. Now you might be wondering, if you're doing backups religiously, there should be no need for recovery, right? Well, yes and no. That's going to depend upon whether you're doing cold or hot backups, and we're going to talk more about that in just a moment as we get into archive logs. Archive log file destination. Now, if you have any experience working with office productivity applications, let's take Microsoft Office as an example, then you're doubtless familiar with the undo and redo commands. Now, I'm drawing arrows that are typically representative of those commands, with the first one referencing undo and the second one referencing redo. And the idea is if you make a mistake in your document, you can press the undo button to step back one action at a time to where you want to pick up and resume your work. Now, if you click undo one too many times, you can step forward in the other direction by using redo. Now, Oracle has both types of data that it tracks changes. That's what this triangle is. It's the delta, the Greek delta letter, to the database. Now, we're going to focus in this section of the nugget not on undo, but on redo. Redo, generally speaking, is more important than undo when it comes to disaster recovery. And our online redo log is a set of 2 or more files. You have to have at least 2 members that will track all changes to the database. Now, changes aren't necessarily selects. We know that data is going to change when we do an insert, which adds 1 or more new rows, update, which is SQL that changes data in a table, and delete, which, as we know, is SQL that removes information from a table. Clearly, those 3 SQL statements are going to result in changes. Those SQL statements and all associated metadata is going to be stored in your redo logs. And the redo logs are written to in a circular fashion. The reason why you have 2 of them actually is as you're making changes to your data or as your users are making changes to the data, each of those transactions is being recorded one after the other in the redo log file. When the first member in the first group gets filled up, Oracle will then jump to the second member. Boom, 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 and go from there. Now, while this first member is free, you can, if you want to, archive it to a backup location, or if maybe you're in a development environment and you don't need to keep redo log backups, you can just wait for the second member to be filled up, and then, as I mentioned, circular logging will occur, and Oracle will gradually overwrite the contents of the first file. That situation of not archiving your redo logs, I have to really stress this, should not be something you're doing unless you're in absolutely a classroom or development environment and you do not need recovery. You can, if you want to, just do daily backups of all your data. That's fine, that'll work. But in the event of a recovery situation, you won't have what's called point in time or PIT recovery. The closest you can bring your data back will be as recent as your most recent backup. Okay? So in any business situation I've been involved in, any production environment I've ever seen with Oracle, you absolutely want to preserve a certain number of your backup logs, your redo logs. So that is going to necessitate configuring your database for what's called archive log mode. Another requirement for using archive log is a need to do online backups. I mentioned a couple minutes ago that you can do cold or hot backups of an Oracle database. A cold backup means that you've gracefully shut down the database and no users are in it at all. You've closed the garage door, so to speak. Now, that's fine. You can do that all day long as you can afford the downtime. Doing a cold backup has a nice benefit in terms of it's fully a consistent backup. There's absolutely no transactions hanging in the breeze or possibly uncommitted. By contrast, if you're doing a hot backup while Oracle is in use, there's always going to be a little hang time there. You may have a transaction in a memory buffer that hasn't been written to a log yet. You may have data in the redo log that hasn't yet been written permanently to the data files. And so by definition, when you back up a hot database, it's in an inconsistent state. And that's why when you come to the restoration side, there's the recovery part where Oracle will bring consistency to that recovery. We're going to do recovery and backup separately later in the course. I'm just wetting your whistle right now. But again, if you're going to do online backups or hot backups, you must have your database configured for archive log mode. That's just a requirement. If you need point-in-time recovery, in other words, it's not enough to recover data to as of midnight, but you need to bring your data back to where it was a minute ago. In that case, again, you need to be backing up your redo log files. Now, the instance processes that are involved are LogWriter and Arc. LogWriter is always there taking redo entries entries from memory in the redo log buffer where they're completely volatile. As you know, any data that's in memory, if the power is removed from a computer, goes up the flue forever and ever. So we really want to make sure that our redo entries get out of the buffer and into an online redo log file as quickly as possible. And that's what the log writer process is responsible for. If you put your database in archive log mode and you specify a backup location for your online redo logs, then another process called ARC, for the archiver process, obviously, takes care of that, okay? So those are our key background processes that are involved in redo log and archive log operation. Finally, you should definitely have your archive logs configured in what Oracle refers to as a multiplexed environment. There are several physical assets that can and should be multiplexed. In other words, redundantly stored on different physical disks. Now, I'm not talking separate partitions of the same disk. That's not going to help us if the entire drive goes up the flue. But if we have data redundantly stored on separate disk spindles or separate solid state drives, then the loss of one drive member will not result in a catastrophic data loss because we have the data redundantly stored elsewhere. Now, what does multiplexing look like? Typically speaking, in training materials, you'll see your redo log file groups shown like something like this. The groups in this case are denoted with the dashed lines. So we have two groups here. I'll just call them group A. Actually, I'm using A and B. Why don't I call this alpha and beta? I guess I'm on kind of a Greek kick now. I have been reading pretty deeply in Greek and Roman mythology, but that's another story for another time. When you install Oracle and you run to create a database, you are required to have at least two files. And you'll have those files spread across two redo log groups. So as I said, we've got group alpha in this example and group beta. Now initially, if you have just a single disk and you do a default installation of the database, Oracle is going to create both of those groups on the same disk, in this case disk A. But as you see in this diagram, we've already multiplexed and created additional members of each group, such that we have disk A and disk B, two separate physical disks, and each group, we have this top one for alpha and bottom for beta. We've created another member on disk B. Now stay with me here. When we talk about multiplexing a redo log file, we're talking about an exact copy. So what's actually being written to live by LogWriter is this set of files right here. So we're going to work on A log 1 and record that redo data one transaction at a time. Now, when this file gets filled up, what do you think is going to happen? Are we going to come over here to blog1? No, because blog1 is a multiplexed member of the same group. All of these transactions are written in parallel over here. That's the whole principle of redundancy. When A log 1 gets full, an event called a log switch occurs, and Oracle will switch to the next group. I envision it physically like an 8-track player. If you remember those, I kind of grew up with those in the late 70s. When you went from one track to another, you'd hear this chunk noise as the 8-track player moved from one portion of the tape to another. That's kind of what I think of when I think of switching, doing what's called a log switch from one group to another. So again, initially, all you'll have is this. It's up to you as a DBA to break out different physical disks and extend each group in a multiplexed situation. Now, you can always, and there are a variety of reasons why you want to do this, force a log switch to occur. You don't have to just let Oracle do it always on its own. When the log switch goes, in this case, from alpha to beta, eventually A log 2 is going to get full. What will be the next file that's written to? You guessed it, circular logging. If you have only two log file groups, then the second log switch will come back to group A or group alpha, and it will start overwriting the contents of A log 1. That's why, in addition to multiplexing your redo log files across multiple physical disks, we also need to configure archive log mode, which, as I said, involves the spawning of the ARC process that will take a log 1 when it's full and copy it redundantly a second time wherever you want. You could store the copy on disk A or disk B, but if you really want to be safe here, you'll have yet another physical disk available where you can store those archived copies. And what many folks do, what many Oracle administrators will do in their backups is run disk to tape backups. The disk to disk backup is going to be very fast, isn't it? Because we're dealing with hard drive to hard drive transfer. That's what this step would be, archiving each log file onto disk C. And then we can run our tape backup to take those archived files out of disk C, which of course would free up space on that disk. And then our tapes could be placed with Iron Mountain or whatever secure long-term storage solution we have in our organization. You see how that works? Now, you can have, as I said, more than 2 groups. You can have more than 2 members of each group. It depends on how safe you want to be and, of course, how much money you have to spend in that process. Now, you might be wondering, specifically, how do we put an Oracle 11g database into archive log mode? I'm glad you asked. Remember, I'm assuming that you have OCA level familiarity so that you know, for instance, what an initialization parameter is. As you see in our example, the first step to doing archive log mode is setting 2 important initialization parameters. There's log archive dest1, log archive format. Now, there are actually 10 locations you can write your archive logs to. _1, _2, _3, etc. And then you just pass in as a string location equals, this is a Windows path, but you can just as well do a Unix, Linux, or Mac OS X path as well, to the location where you're going to be storing not your initial logs, but your archived logs. So if I come back to my previous slide, I would set the parameter to point to this disk here, disk C. The log archive format initialization parameter is used to customize the name of the file. And we'll talk more about this substitution variable, this %s, %t, %r later. I'm just going to let you know that this is a coding system that enables you to substitute in metadata, things like dates and sequence numbers. The resulting file in this example is going to look pretty long, pretty gnarly at first blush, but you'll want to document your files as much as you possibly can. Believe me, that'll pay off in a recovery situation. After we set those initialization parameters, we're going to bounce the database. We're going to shut it down cleanly and start it up in mount mode. So the instance will be initialized, the database will be mounted, but not open at this point. It's important. So no users are going to be in there. We then log into the instance using SQL Plus or whatever and issue alter database archive log. You do that, that command is accepted, you can then open the database and you're in business. Now, if you don't like SQL, you can always do this stuff graphically using OEM. That's Oracle Enterprise Manager, you'll remember, and that is a web-based GUI utility that really we can do anything in this entire course using OEM, and I'll make sure in our demos, in most cases anyway, to show you how to do it both ways, because you never know. You may see some screenshots from OEM and you'll be asked to interpret what you see. So I would suggest strongly you not take a prejudicial attitude toward graphical utilities like OEM. I've run across, I'm not going to say many, but I'll say some Oracle DBAs who are quite snide about anything but a command prompt. I think that's a little short-sighted myself. Now let's talk about the flash recovery area, or as it's affectionately referred to, the FRA. What this is, friends, is a central location for backup data. We're talking about log files, entire backup sets. We haven't defined backup sets yet, but we will shortly in an upcoming nugget. Backups to control files. What's cool about the flash recovery area is that it's one of those set it and forget it initialization parameters. The actual path or destination you use for your FRA can either be local file system or you can point to an ASM disk group. Very convenient. What's neat about this, among many reasons, is that you can point your RMAN backups. Actually, scratch that. You don't have to point RMAN to any location when you're formatting a backup. You don't have to format a backup really at all. You simply issue backup database, boom, or backup database plus archive log, and you're gone. FRA will automatically be, or as an old colleague of mine, Jeff Kane, used to say, automagically be the target or destination of those backups. Retention policies, something we're going to discuss very shortly. This is an RMAN property that allows us to determine how long RMAN will keep backups. FRA really represents an easy button, if you're familiar with that, because RMAN will automatically expire and purge outdated backups. You don't have to do anything as a DBA. Configuration of the flash recovery area is pretty easy. It's simply setting properties for two initialization parameters. There's DB recovery file dest, which is the file spec or the file path, and DB recovery destination size. This is going to be the size of the pool, as it were. Now that is a particularly important figure to consider. We want to size our flash recovery area with plenty of room. Now, how much room specifically is going to require that we are reporting on our backups and we know about how big of a disk footprint to expect each night, you see? And by the end of this course, you'll understand how to do reports from RMAN, so you'll therefore be pretty well armed. You can always change these values later. It's not something that you're locked into by any means. This slide shows us the specific SQL commands or SQL plus commands for setting the flash recovery area. We're setting the DB recovery size initialization parameter in this example to 4G. There's a special nomenclature you use, M for megabytes, G for gigabytes. Believe me, I've tried to do 4GB and gotten errors, so it's just one of those things you have to know. DB recovery dest is simply a string that points to the Unix, Linux, or Windows file spec for your actual flash recovery area. And you can always obtain metadata by using your $V dynamic performance views. You can run select star from $V recovery file dest to get usage statistics to help you with sizing, as I mentioned before. Then you can simply fire up RMAN, our command line recovery manager, and run commands without having to specify a target location. Same thing with restores. Restores don't have to involve a great big file path where you're pointing to a specific file. Oracle will completely handle that for you, which I think is a really great thing. Retention policy, as I mentioned a couple times, deals with RMAN configuration settings that specify how long it will keep backups. If we're using a flash recovery area, RMAN will auto-purge when backups are obsolete. If you do not have a flash recovery area, you'll have to manually delete backups as they reach and go past the retention policy. Now, some Oracle DBAs I know, I'm not going to call them control freaks because you might perceive that as pejorative, but I'll just say like to have maximum control over what's happening in Oracle. Therefore, I think it's cool that the Oracle people don't force us to use a flash recovery area. We don't have to if we don't want to. It's really up to us. Now, retention policy applies only to full backups, level 1 backups, not incremental backups. And the main reason for that is that our full backups are our core foundation of recovery. We can't very well expect to bring back data with simply one or more incremental backups. When we set retention policy, there are two methods. We can set the retention by redundancy, which is a certain number of backups, or we can use recovery window. Now, the default is redundancy, but Oracle in their documentation recommends that we use window wherever possible. A recovery window-based retention policy instructs RMAN to keep your backups, your full backups, for a certain number of days. To me as an administrator, that makes more sense than arbitrarily saying, I want you to keep 3 backups. You see what I'm saying? Let's say we set redundancy to 3. That would mean backup 1 finishes completely, it's considered current. We back up full again, still both of these are retained, they're considered to be current. Third time we back up, guess what? 2 and 3 are considered current, 1 is going to be marked as obsolete and ready to be purged. Well, you know as well as I do, with this situation, you might discover during a disaster recovery situation that backups 2 and 3 are somehow corrupted or incomplete, and you actually needed 1. By contrast, if you set a recovery window of 7 days, then you can definitely rest assured on Thursday that if you need to bring back Tuesday's data, you can do that with no problem. Again, report Reporting can occur either using $, dynamic performance views in SQL+. We can use the Oracle Enterprise Manager console for a graphical approach, or we can inquire directly in RMAN in terms of seeing what's obsolete. And if you are in an emergency, even in an FRA situation, and you need to free up some space, you have the ability in RMAN to do that, to manually purge backups. Heck, you can even purge current backups if you want to. This whiteboard shows us how to configure retention. Now you see here, the first line says RMAN target /. What does that mean? Well, we haven't formally defined or gotten into RMAN much yet. I'm going to gradually disclose little bits, and then when we formally discuss it, we're going to go deep, and you'll understand all about it. But from an operating system prompt, as long as your Oracle home bin directory is in your search path in your host operating system, you can start the RMAN executable just by typing RMAN. Now you also need to specify a target, whether that's a target database, a target recovery catalog, or both. In most cases, if you're connecting just to a target database, you specify target, and then if there's just one Oracle SID, whatever one is active on your computer, you can specify your credentials next. / is easy if you're using operating system authentication and you're logged on as an Oracle administrator. Makes for a really clean way to get into RMAN. Once you're in the RMAN environment, we can use the configure command to set defaults that RMAN uses during its jobs. You see, configure retention policy 2 is the stem, and then we specify either redundancy with a certain number of backups to be kept current, or recovery window where we specify a clause of a certain number of days. If we want a clear retention policy and start over, remember the default is redundancy, we would specify configure retention policy to none. This is our demonstration on configuring for recoverability in Oracle Database 11G. We are on a Windows Server 2008 R2 domain controller named OraNugget, and for you Linux Unix folks, don't worry at all that the majority of these demos will be in Windows, because the tasks and skills we're learning are all completely operating system agnostic. As you know, we're going to be working with the RMAN utility throughout this course. We'll be using SQL+, and we'll also be going into Oracle Enterprise Manager Web Console, all of which behave exactly the same way, regardless of whether you're on Mac, Linux, or here in Windows. Our first task is configuring multiple archive log files. And as we know, we need to put the database in archive log mode. So walking into a new situation as a consultant, let's say, you need to figure that out, don't you? So how can we find out at a glance whether or not the database is in archive log mode? Well, we can do that from SQL+. I'm going to log in as sysdba using my operating system account, the account that I'm currently logged on with. And as far as the ins and outs of SQL+ in this operating system authentication, if you're not clear on that, you really should be. But if you're not clear on that, make sure to go back and check out my CBT Nuggets training series on DBA 1, where we cover that in exhaustive detail. If you're an annual subscriber at CBT Nuggets, then you can easily get over to that course. Now that we're in SQL+, we can run select log mode from $database, one of the so-called $views, and that will tell us at a glance whether or not we're running in archive log mode or not. And it looks like in this particular example, we are in fact running in archive log mode. We can also take a look at those parameters that govern the behavior of archive log mode. We'll do a show parameter, log archive test _1, and we'll see that I have in fact hard-coded a location of C archive logs for my log mode destination. Now, if I was not running in archive log mode, then I would have simply empty values for all of these log archive desks. And as we already discussed, came out in the theory portion of this nugget, we can in fact use more than one location, including the flash recovery area, which we'll get to shortly, as the default save location for our archived redo log files. Another thing we can do is go to Oracle Enterprise Manager. I'm going to show you the graphical way to go here. Once we're logged into the instance, we can come over to the availability page. Under Setup, we'll go to Recovery Settings, and then we have Media Recovery. Now we can turn off archive mode just to give us the experience of doing it through the command line. In the graphical interface, you can do that simply with a checkbox. And note also we have the other parameter, which we can get to again either through the graphical interface or through command line. Let me come back and we'll run show parameter log archive format. That'll just simply give us the format using these substitution variables to tell us that in this case our archive log files will have a unique name. And we can supply or customize the order or use of these substitution variables just depending upon what we want to see that makes sense to us. Simple as that. I'm actually going to come back to OEM and turn off archive log mode so we can re-enable it. I want to show you how that works. If you're on the newish side to Oracle, I want you to, as you get familiar with both the SQL Plus and Oracle Enterprise Manager interfaces, get used to this Show SQL button. The way this works is if you make a change, depending upon what the change is, it looks like it didn't consider archive log mode uncheck an operation. But if I were to change this instance recovery value, we're actually going to talk about this shortly, we can show the SQL to see what's actually going to happen under the hood. Setting archive log, either turning it on or turning it off, requires restarting or bouncing the database. In this confirmation message, it's asking us, do we want to restart now? And I'm going to answer yes to that question. To do that, we're going to require credentials, both operating system credentials, my Windows account, as well as I'm going to use my sys credentials as sysdba. I'm going to save this as a preferred credential, and then we'll come over to OK. This is giving us what's going to happen under the hood. It looks like we're changing an initialization parameter, and that's going to be recorded in the SP file. That is, in fact, what we want to do. We can show the SQL if we want. I'm going to choose yes to complete this operation. And now we have the opportunity to refresh the page until the database comes back. All right, we're back in business here. So let's come back to SQL Plus, and I'll use my up arrow. I may have to get back into this database. Let's see. Yep, so let me exit, clear the screen, get back in. And let me verify that we're not in archive log mode by running the previous query. That's true. And verify that we still have that. We can clear this out if we don't want to store this value. But what I actually want to do is point to a new location. So let's open up Windows Explorer on the computer. And I have a second drive on this server, my F drive. I'm going to create a folder very quickly here called archive logs, just like the value that you see there. We're just basically changing the drive letter. And to set that parameter from SQL Plus, we can run an alter system, set log archive dest _1 equal to single tick, because I'm providing a string for the value. And it's a little bit wonky. Instead of providing just the file spec or just the path, you prefix that with location equals and then the path. Archive _logs, end string, semicolon to terminate. And now if we show the parameter again, it should update, which it certainly does, to our new location. Now we can change the format as well. We can run an alter system, set log archive format equals, and I'll say ORCL, that's the short name of my database, %R _%T _%S.arc. Scope is the server parameter file. This is not a dynamic parameter. We're going to have to restart to put this into effect. I'm going to come back and close out this string and then throw our terminator after SP file. And now we've got a shutdown and startup in mount mode. So I'm going to issue a shutdown because I don't have any other users in this database. And I know I don't have any open transactions. I'm going to run a quick shutdown, a shutdown immediate, and we're going to issue a startup mount to mount the instance and mount the database but not open it. Gives us our instance memory counters. The database is mounted but closed. And finally, to finish this off, we can just do an alter database archive log, submit that, and then open the database. And we are back in business. All right, cool. Now let's force a backup of a file, right? Let's force a log switch. Let's do an alter system, switch log file. Whoops, you probably noticed that instead of F archive logs, which is the correct path we wanted, I had specified D. So let me quickly correct that, and then we'll force another log switch. Because of course, if I check F archive logs, the folder is empty because Oracle is trying to back up the archive logs into a different path that we're not interested in. So no big deal. We'll just run an alter system, set log archive dest1 to, again, the location of F archive logs. There we go. That was a good review for us, wasn't it? That's one way of looking at it anyway. Alter system, switch log file. We know exactly what that does and why we would do that. This means we can now open up our F archive logs folder and see those archive log files as they get created. If you're interested in more metadata about your archived redo log files, you can get to that from OEM, of course. From the Oracle Enterprise Manager homepage, we can go to the Server tab. Under Storage, we can go to Archive Logs, and that will show you your archive logs as they're created in this reverse chronological order as you see. You'll notice that we switched from the previous archive log destination, C archive logs, to our new one on drive F. We can click one of those ARC files just to get specific size, sequence number, container information, etc. We can also, in this object type filter, take a look at our redo log groups, the active online redo log files, and you can set those up to your heart's content and force a log switch, force a checkpoint, clear a file, depending on how you want to handle that. Now, without any further ado, let's switch over to the flash recovery area. Now, this is, as you know, called the fast recovery area in current Oracle documentation. It's probably going to take a while before Oracle DBAs get used to the name change, so just get used to the FRA representing either the flash recovery area or the fast recovery area. It's the same thing, actually. I'm going to put my FRA on my drive F, and I'm going to call it easily enough FRA. Now we can get to this graphically in the Oracle Enterprise Manager. Let me come back to the instance homepage. Through the availability page under recovery settings once again, actually where we just were when we toggled our archive log, the location, and the file format. If we scroll down a little bit, we can get to this graphical area for flash recovery. See, even the interface here is calling it flash recovery. Now graphically, we can just type in the path and specify its size. Now, as you know, under the hood, we're manipulating initialization parameters. If we look over here on the right, it shows us our current usage. Now, I'm a very colorblind person, so this color coding means essentially nothing to me, unfortunately. I would rather just see numbers. If we want to manipulate the FRA through SQL+, that's perfectly okay. Let me run a host CLS to clear the screen. Well, first let's run the show parameter db_recovery just to see relevant initialization parameters in this view. And we already know that the current value is CRFA or FRA and that the destination size or the max size is 5 gigabytes. Now note that that's 5G, not GB. You actually will get an error if you use a syntax that's not correct, which of course is to be expected, isn't it? Now to customize the FRA location, we can run alter system set db recovery file dest. We'll set the first string value first, equals, and then I'm going to make sure I get my drive mapping correct this time, FRFA, and we're going to scope that to the SP file, the server parameter file. We're going to have to reboot, in other words. This is not a dynamic parameter. Next, we'll run alter system, set db recovery file dest size. Let's make that 3 gigs instead of 5 gigs. Actually, I won't cut it down so dramatically. And now I'll do a startup force. Startup force is a nice shortcut way to bounce a database. It's going to do a shutdown immediate, which of course is not something you want to do under normal circumstances. We're in a development environment on my computer on OraNugget, so it's not a big deal. But it enables you in one shot, in one command, to do a hard reboot of the database. That was pretty fast, wasn't it? We're already in and ready to go. Now we can verify that change just either by looking at those initialization parameters there, or we can come back to Oracle Enterprise Manager, and sure enough, our path for the flash recovery area location has been updated, as is the flash recovery area size. Pretty easy. Our final subject in this demo is RMAN retention policy. Now how are we going to do that? Well, since we're already in Oracle Enterprise Manager, let me show you where that lives. We'll come back to the instance home page. On the availability page, we'll go to backup settings, and then we'll go over to policy, retention policy. And you'll see here in the graphical interface, we can choose to retain all backups, which would only be relevant for shops that have very strict compliance requirements, or more commonly, we can either use a backup window or a number of backups. Basically, we've got recovery window and redundancy as our keywords, and right now we're set to retain just one full backup. Now, if you want to change that through Enterprise Manager, it's pretty darn easy. We can just choose another radio button and click OK, but we want to make sure we understand both ways to operate. So let's exit out of SQL+, we'll clear the screen, and we'll log into RMAN using our current operating system credential, and we'll connect to the ORCL instance that is my default Oracle SID on this server. First thing we'll do is run a show all just to get a run of all of our current settings. You'll remember that any settings that are at a default, at a factory default, show up with hashtag default after it. Can be hard. My eyes cross pretty quickly when I see a list like this, especially all in uppercase, so you can look at a specific parameter if you know its name. I'm going to do a show retention policy, and it tells us that the configuration parameters for my ORCL database is redundancy 1. Well, we know that, don't we? We can blank that out very easy using the configure command, configure retention policy to none. Now, if we arrow up to show the retention policy again, it's just set to none, right? There's nothing there. Let's say we have a business requirement that requires that we keep our backups, have them be in a valid state for 4 days. Configure retention policy to recovery window of 4 days. There. And let's actually validate that by going back into Oracle Enterprise Manager and refreshing the page. And there you have it. Done and done. Configuring for recoverability review. Now, the reason I threw in that information on sources of failure, even though that's not specifically or strictly speaking an exam objective, is because I want to make sure that our discussion is properly framed. I thought to myself as I was preparing this nugget, it doesn't really make much sense to me as a student to just jump right into stuff like archive log destinations and configuring archive log mode, setting RMAN retention policy, and understanding the flash recovery area unless we understand why it's important to do those things. And I hope you'll agree with me that reviewing those sources of failure might make you a little bit nervous as a DBA, thinking, well, there's a lot that can go wrong in Oracle database, and that's absolutely true. But the good news is that we're learning all of these neat tips, tricks, and technologies, most of which are all built into Oracle 11g by default, that can minimize, mitigate, and in some cases eliminate the possibility of some of those failure sources from occurring. So I hope you got a lot out of this nugget. I hope that this has been informative for you, and I'd like to thank you for viewing.